Hi, my name is Rob Canzaneri, and I'd like to welcome everyone to the PASS Data Architecture virtual chapter. Today, we're going to have Steve Simon presenting to us, and I'd like to thank him for presenting to us. And I was going to talk a little bit about PASS right now. PASS sponsors SQL Server Saturday events, and we're going to have quite a few coming up, and I will screen here with upcoming events. PASS also has the Business Analytics Conference this year in San Jose, California. And we also have speakers every third Thursday of the month, and I'd like to thank everyone for attending. So right now I'm going to turn it over to Steve and let him start the presentation. Hi, Steve.
Okay. Can you see my screen?
I can.
Good. Can you see the main slide now?
Yes, sir.
Great. Hi, everybody, and thanks very much for attending this presentation. My name is Steve Simon. I work for Atrium Networking Corporation in Providence. And I'm here to talk to you about my hobby horse. I'm in the BI business right now myself, and over the years I worked first for a major financial institution in the Boston area, and then I worked for an online grocery service up in Burlington, Vermont before coming here. And they always say that hindsight's 20/20, and there were a couple of lessons that I learned in both jobs, and I put a couple of these things and a couple of thoughts together on a PowerPoint presentation, and I had actually presented this a bit earlier in the year. So for those of you who caught it earlier in the year, I hope you'll bear with me on this one, but I think that you're going to find revisiting the subject is actually quite interesting, and you get a couple of thoughts of really sort of how not to do it. You know, sometimes it's difficult to be able to find the right way to do it, but this is definitely the way not to do it. Okay. Just a couple of little paperwork. I am a SQL Server MVP, and I'm in business development, business intelligence development. I work for Atrium, as I said, and I am a PASS regional mentor for virtual chapters, and I'm the chair of the Oracle SQL Server virtual chapter. So if any of the people out there in audience land are doing both platforms, I'd love to hear from you, because we're always looking for presenters. It's very difficult to get presenters that have the experience on both sides. Okay? For those, I shall have the presentation, including all the codes, up on my website. I normally put in a QR code there for you guys with the Androids and Windows phones to sort of get the QR code, and it'll get you directly to my website. All right, let's get into the meat of the subject. Warehouse design will change with time, and sometimes when we go and develop a database warehouse architecture, we tend to start off with preconceived concepts of how things should really look. And sometimes these get the better of us, so that we start designing it in one particular way and haven't really thought the thing out carefully in all details. Now, obviously, there are limits to the amount of thought that you can put into it, especially when you're starting off. However, you know that these things evolve with time, and any basically appearance as, from the final example as to what it was in the design stage is purely coincidental. And you're going to see some of the challenges in this particular case that we achieved in, number one, when I was working for the Financial Institute, in developing a Oracle and SQL Server combination warehouse, and when I was up in Burlington, basically doing it within the SQL Server world. And you'll see some of the performance times and how we basically, sort of fixed it up by changing the architecture a bit. Okay. As I mentioned, two practical examples will be used in this. One, a financial particular example, and it's oriented financially, and the other one towards groceries, but yet, in many ways, it's financial as well. Once upon a time, there was a financial data warehouse, and I sort of give it the subtitle, How Things Could Really Run Amok. And it really is true. After having sat down many times and sort of wished that we could do things over and over again, right? And we're going to talk about the Michael Jackson design technique. and just to give you a heads up on this one, this is not anything to do with Michael Jackson, the singer. There was a guy way back when Noah was a little lad. His name was Michael Jackson back in the early 70s, who came up with the idea that your database structure should be really designed according to the reports that you want, to type of reports that you want to pull out. In other words, if you're doing general ledger reports, your final warehouse table should be generally oriented towards the thing. Denormalized, Cod was a little boy at the time, back in the early 70s. And Jackson thought basically the way to do it is to make sure that wherever you're going to put your data in, whether it be flat files, in those cases it was mainframe files, COBOL, the equivalent of DB2 or early phase DB2. Keep the data in separate tables, but it has to be pertinent to the actual report. This way you're going to have less I/O, which is always a killer, and also, pain and strain trying to get things out. So we'll be talking about that a little bit further on, all right? Now, the problem with the financial warehouse is it was designed specifically as a warehouse, or it was intended to be a warehouse, definitely intended to be a warehouse. However, if I did a little bit of an extract of the tables that existed at that particular time, and obviously the data here is bumped because of the fact that it's financial data, and I've had to remove a lot of that. You can see that in this particular diagram, we've got a financial fact table where you've got the amount of money, and you've got a couple of dimensions there, fund owner, owner address, and address, etc. Okay? And these are the type of things that you would normally get in a third normal form on a Boyce Codd diagram. So what's all wrong with that? Well, I don't have to tell you anything here. It's a particular relationship diagram. If you can see how things go from one place to the other. And this is only because of the fact that things were added on afterwards and had to, sort of be tied in to make a whole comprehensive model. Right? But you can see that I got spaghetti all over the place. And I'm not telling you anything you don't know. But I think once you see how we resolve the problem, you'll be able to get some common sense out of what I'm trying to show you. All right, so that was a major factor, and this is, I want to say, about 2-3 years down the project. This is just obviously a small subset of what we had, right? Here's the kicker. We had a lot of relational spaghetti. Now this, God is my witness, and I got to go to church on Sunday. This is some of the queries that were actually pulled and put into place because of the fact that the design of the structure was totally crazy. You can see in red, I've sort of put all the inner joins in there, and there's a left outer join there and a couple of left outer joins, etc. All right, and you can obviously see that you got total chaos in there, and this is a result of, I think personally, not doing the best job on planning. All right, so these are some of the challenges that we faced, and we'll talk about. We had one particular office in Munich, and I might as well tell you here what happened. A couple of the guys in the Munich office, while we were sleeping here in North America, decided to run a job and run a query, etc. And what happened was they were looking for some results, and they decided what they were going to do. And these were, power users that had an idea of what to do with views, etc. And they decided they were going to run a query, and in their infinite wisdom, they decided to hook up another small view to it to try and find out somebody with an obscure field, and you'll see it actually in the diagram coming up. They decided to attach this other view to the query, and they set the query running. Anyhow, the query ran, to keep the story short, the query ran for something like about 25 hours and returned 4 rows. And this is obviously a strain on the system, and obviously really comes back to the root cause. If you're going to do a root cause analysis, a very, very poor design. Okay, now at the time we had about 1,500 queries and a couple of extracts. And in the inventory file, you can see some typical, fields that were being pulled. All right. The challenges that we really faced were that the users, the end users, both the power users and the BAs and the whole 9 yards, these were users that expected the reports to be returned in under 30 seconds, okay? Which is not really a bad amount of time to return it. Now, you got to remember one thing. In many of the tables, we had far in excess of an American million or a milliard in European terms records. Now, obviously, going through those particular records, and the kicker is that some of these tables had somewhere, or the views had somewhere near between 200 and 300 fields within the views. So you can imagine this would be a great paradise a couple of years, back for column index storage, But at that time, obviously, we didn't have these things. And as a matter of fact, when the whole thing was first set up, there were no indices on views. So this did create a sort of problem, and we'll be talking about that when we talk about the DAO, the data access layers that we sort of implemented. Okay. Now, the problem is when resubmitting the reports, when no reports came back, we had middleware failures and tie-ups. Now, what happened was that when you submitted the report, it went through the middleware, went up to the databases, pulled the stuff back, and came back. But sometimes when you had a very complicated report, what tended to happen is that the results had never returned back to the client. And obviously what happened is when the client received no results back within the, say, 30 minutes, what he would do is resubmit the report. And eventually it brought the middleware down to its knees as well. So obviously we have performance issues. Okay, so what's the solution? Well, as I said, going back to Michael Jackson, we really want to sort of get our tables, this is one possible way of getting your tables based on subject area and the report type denormalized, okay? Just for the reports. We want to make sure that they're well indexed, okay, especially. Now, the problem is, if you recall what I said a couple of minutes ago, I talked about the fact that when this thing was first implemented, there were no indices that you could put on a view within SQL Server. So we're talking about release 1 of SQL Server 2008. So really what it boiled down to was the fact that if you wanted to get these things well tuned, etc., you had to give the users access to the tables, which we all know is a no-no. Otherwise, what happens is we're in the development of query business. In other words, they say we need a this and a that, and then you've got to, you know, basically speaking, produce a report, and you spend all your time doing reports. So it really was really a lose-lose scenario, all right? But the thing that you have to remember is it's easy when you're using a table, you're easy to populate what is required in these type of things if you set your table structure according to your reports. Now, you're going to have some wiseacre out in the audience that basically says, yeah, well, what happens if the reports change? Well, the whole thing is an evolving system in any case. So you're going to, we all know that no system is set in stone. Every particular system that you design has to evolve. It goes through the whole life cycle, the software life cycle. And you're obviously going to have changes as you get ahead. Okay? All right. All right. Okay, so moving on. There is somebody out in the audience that's got a question there. Question. Oh, yeah, there's feedback. I don't know why. It's not on my side. Sorry about that. Anybody there on the other side that can give the feedback, fix the feedback? Okay. All right. I'll try and move a bit away from the speaker in case it's me that's causing this. How do we basically develop our queries or get the queries to the users so that they can do all the work? Now, just to give you an example,
Steve,
a couple of days ago, I just came back from Amsterdam. I did a presentation on master data services at the Pass SQL rally in Amsterdam. I'm trying to promote here and over the air that users take responsibility for their own data, especially data that's not financial. Bob Smith moved recently, and he basically, sorry, is somebody calling?
Yes, hi Steve, you might step closer because it's harder to hear you now.
Okay, right. Better now?
there's no more feedback.
Maybe a little closer.
Okay, I'm here.
That's a lot better. Thank you.
Right, great, no problem. Sorry, folks. All right. What we did was we wanted to empower users, and we want to be able to give them the facility to go and draw their own data and all the fields that they need and let them go and write their reports. But yet, the caveat is this. What we want them to do is to be able to do it efficiently and effectively and not bring the system to its knees. So at this time, what we did was we decided we were going to create what we call data access layers. And this has nothing to do with what they put in Visual Studio back in 2005. This is something unique. It's dealing with functions. And this way we could make sure that our warehouse architecture was correct. What did it do for us at the time? Number one, we were able to get the DBAs and myself and a couple of other people to be able to develop the code that would include a lot of fields in there based upon what the users wanted, and be able to put it inside a function and let the user call the function. Now, these functions were called data access layers, and you'll see it in a couple of minutes' time when we go into a demo, practical demo. But what we gained on this was, number one, we were able to take advantages of the indices on the table. Number two, we were able to tune the queries as best as we possibly can. And number three, which I'm going to show you as well, is they're easily clonable. And inside some of these queries, we put in 200, 300 fields, and all they have to do is pop in the fields that they want and basically buy a subquery. And we'll have a look at that in a couple of minutes too when we get into the practical side. Now, what is a DAL? A DAL is a function, in our particular case, and joins two or more tables and returns a result set that containing a myriad of data fields. In other words, a whole clump of fields. Now, as far as I'm concerned, my mom used to say a picture's worth 1,000 words, and I think a DAL can be really classified almost like, to give you a good picture, a metaphor, is a bowling ball, where you've got parameters in, actually they're arguments into the parameters, into the bowling ball. The black ball inside the black box, whatever you may be, it processes the goodies and pulls back the data and gives you your results set out. And we'll have a look at that in a couple of minutes' time. Right? So we have a data warehouse, and before the users used to access the data via views prior to the DAL. All right? And that's where we landed up with our major amount of trouble. The users used to create, many of them used to create their own SQL to extract their data. Now, this is the dangerous people. These are the dangerous people that we have to watch out for, because they have a certain amount of knowledge, but yet they're not trained, and very few of them. And I think if you, to thine own self be true, if you ask yourself, what's, how well do they know it? How many of them, and I ask you with tears in my eyes, I say to you, how many of these people have actually experienced using a query plan? How many of them have ever even looked at the query plan that their queries generate? Okay. And in doing so, obviously, they would see some of them are pretty inefficient, and normally they're obviously table scans. Okay. And the other problem that we had with their queries were they basically were not structured in an optimal manner, which we basically overcame by using the DALs. Right? So just to give you a little flavor for it, I'm giving you two subject areas that we've got right now. We created a general ledger DAL and a position DAL. Okay, now you would get joins. It does not necessarily DALs; they were just views. Let's put it that way. Okay, that should actually read view. So people would take an obscure view. There's the general ledger and the position on top. That's another little top view, and there's an obscure view, etc., and another obscure view, etc. And they would join these things together, and they would try and bring out, the best of every piece of data that they wanted, whether they needed it or not. Now, the problem is that joins were being made willy-nilly. That Munich story is God's honest truth. All right. CPU went through the ceiling. You can obviously understand because it's churning up. It's doing all sorts of table scans. All right, which we all know do not increase the effectiveness of the system. Okay. You basically understood execution plans, as I said before. Okay, and the result set was, now this you obviously have hit yourself if you've been in business for any time. The complaints go up the ladder, especially when you're in a big business, and they come down and they say that you can't get any data out of the system, and the system is pretty poofy. All right, so as a result, many of the queries were sent back to us to be optimized, etc. Therefore, you had people's valuable FTEs doing a certain amount of restructuring of queries, etc., which is not really on. Okay. Now, after doing a little bit of work on this one, what we did is we found 10 sites. Out of 10 sites that we had, we found that there were a lot of reports that had a lot of things in common. We looked for ways to pull the data with the most optimal execution plan straight across the board. Now, as I mentioned to you earlier before, we have millions and millions of records in most of the tables. And honest to God, there were some places of a milliard records, M-I-L-L-A-R-D, M-I-L-L-I-E-R-D, or 1,000 million records within the databases. And that's on the small side, all right? But Michael Jackson's sort of ideas, again, came to rescue. What we were doing, in short, in creating these DALs was to pull from the tables, but with an optimal execution plan. And as I mentioned before, the DBAs and myself and a couple of other guys sat down, and we basically speaking restructured the whole thing. And got the reports together, took a look at the reports. What do we need? Where's the best way to do it? What's the best execution plan, etc. And then basically encapsulated that whole piece of query into the DAO. We took advantage of the table indices, as I've mentioned numerous times before, because at that time you could only put an index on a table. We avoided pulling from a lone field, this way in a view. This way, because we don't have the views anymore, we have no issues. All right, henceforth, the birth of the DAO. Now, here's an example of the view help. If you'll notice down there on the slide, you can see that the fields, I cut the field short there because I couldn't really want to show 200 fields within the actual view layout. But you can see there that there's a pretty well good structure of what it was, and there's over 101 fields in the DAO, in the view. This is a view, not the DAO. Okay, our plan of action. Architecture changes. The architecture prior to having and working with these DAO functions was to have a database, a standard, with tables, a couple of views, and the end user at the bottom. I'm not telling you anything that you don't know. All right, and this is what basically caused us a lot of problems. Now, the architecture with the DAO was slightly different. What we had is we had the database structure, database at the top. We have our tables, but we've removed the views, and we have the DAO layer underneath. And the DAO returns to the end client. Now, it boils down to basically using the efficient use of the table indices that you have within your table structure. Now, the coverage that we have, or we had at the particular time, was the following. In banking terms, we have the positions, where the account stood on a particular day. General ledger, transactions going in and out. All right, I mentioned transactions, all right, and lot level data, because I was in the mutual fund business and everything is sold in lots. So it gives you an idea of what is basically speaking being covered at the time. Now, here is a sample function of the DAO. What I would do is, within the actual DAO, what I would do is I would have the black query is a super query, and what it does is it gets the data from the DAO, and what I do is I pass through a couple of arguments in the parameters position, and I give a start and I give an end date. And as a result, what you do is you get some values out. So, moving on, let's have a practical demo. Can you guys still see my screens? I'm working on 2013, and one of the features of 2013 is that you cannot see, once you're in PowerPoint, it sometimes becomes difficult when you're duplicating your screen to see what's actually going on behind the scenes. Okay, so I want to go into SQL Server right now. Okay, and can everybody see SQL Server here?
Yes, Steve, we can.
All right, I know what I'm going to do. Open. Okay. Sorry, Dave, can you see my screen? Okay, I'm going to
Yes, I can see it. Yeah, I can see it.
Can you see the code?
Yes, sir.
Thank you. Sorry, folks. It's just, as I say, when you go and do presenting with 2013, you'll understand what I'm saying. All right. Here is a piece of code that goes behind the DAO. and basically speaking, what creates the DAO. Now, I believe I did a rough count, but I think there's about 4,000 lines of code in here. So there'll be a query, there'll be a test afterwards on the content. So be very careful as I go down the code that you memorize everything that's there. All right, you get the idea of what's there. Now, I'm just going back up again. I'm just kidding with you. Right. Here's the function, and here are your parameters that are being passed in. All right, I've got a couple of defaults there because you obviously need some defaults. Now, what it does is it returns a result set of a table. All right, and here are the various different fields that are being rendered from the DAO. These are the fields that will come back. You can see there's obviously about 200 or 300 fields in this particular example. All right, and it does a lot of complex joining. But the kicker is this: the kicker is that what is being done here has been optimally tuned according to user requirements. So that when you actually create your DAO and you have it to performance tuned, then you're in a great position to actually physically run the product. So if I go now and I go and open some actual practical code, say here, you can see that what I've got is I've got my standard use statement. This is just a pretty simple example, all right? And you can see that I'm choosing a couple of fields in here. I've got the fund ID, the asset ID, the calendar date, the system that this belongs to. There's a couple of things in here. This particular OTC thing was done as a union all to a couple of other tables that were imported. And you can see I get it from a particular function. You can see that I've got a whole pile of fund names in here, which are pipe delimited. I've got a asset ID here, which is a number, and one of them is letters. And I've got a start date and an end date to my query. Now, you can do anything you want with these DAOs. You can make the parameters anything you want. You pass through, only thing that you have to do is pass through your predicate arguments into the system. All right? And if I execute this one, first of all, let me debug it. Yeah, it seems to work, and I execute it. I get my data back. Now, in this particular case, what it was is it is a concatenation or a union all of 3 different databases. You can see in this particular case here, I've got some data from the FDR database, some from the OTC database, etc. And in this particular case, what I've got is I've got a fund ID, I've got an asset ID, and I've got a calendar date of this transaction occurred and the system from which it came. Now, what I could also do, if I wanted to, is I could say take the market value in base currency. And what I could do is I could then put that in here. And I could run that. And you can see that I've got the market value here. Look at how easy that came. Now, remember one thing. The one thing that you want to remember is that if you're going to do any performance testing, make sure you clear the system cache before you do any testing. But I've got in this particular database, I think it's 65 to 100,000 records. And this is just, you can see how fast this comes back. And if I wanted to, I could pull any of these particular fields out. Let's take another one, terpsichore, and put it in there and run it. And unfortunately, it is 0, but you get the idea. I mean, so this is really, really, really a cool way of doing things. What do we get out of the thing? We get peace of mind that people are acting and pulling data off the system in the most optimal manner under the circumstances that are considered. You'll find also that what you can do, and perhaps this is defeating the purpose. I want to just show you one more example in here. By opening up this one here, I think it's passed through 3. Is this the one I'm looking for? Yeah. A lot of people asked me at one of the presentations that I did, and I was actually quite interested in this one. Even though we're using DAOs right now, is it possible to join to any other table through a view or whatever it may be? And the answer is yes. What I did was I created a view called active or closed. I think it's a table or a view, whatever it may be. It's been so long since I've looked at it, but you get the flavor. What I'm doing here is I'm using the DAL and joining that DAL function via inner join to active or closed, etc., where the fund IDs match, and then I group by it. Now you'll see right over here what I'm using is I'm using the same database DAL, and then what I'm doing is I'm freeing the session cache because I've used this for doing performance testing. So if we have a look at that thing and execute this particular query, you can see that what I've got here is I pulled the active for this particular fund, M1TE. I've got the asset ID. There's the asset ID. This is 105, etc. Here's the calendar date on which it was issued. And you can see right over here that here is the issue amount. Now, a lot of these records in here are basically speaking bumped for obvious reasons, but you can see that the dates have incremented, etc., because there are a record for every single date. And you can see that in some of these particular cases here, there's 1 or 2 records per day. But the point and the important point that I'm trying to get across here is that you can make these things do whatever you want. Now, if you're going to do an inner join to a view and not defeat the purpose of using the DAL, they're normally small tables, I call them helper tables. Like, for instance, is something active or it's not active? You normally have a fund that's active or something that's active, a club that's active or it's not active. And it's just a 2-field name, and there could be maybe 300,000 funds. But, you know, if you have 2 fields and they're small and you're using a Boolean for whether it's active or it's not active, and the fund name has only got 4 characters, you can obviously see that it's not going to be a big deal to be able to do a view against something like that and then join it to whatever you've got off the DAL. Remember, it's got to be used by production, so we really have to sort of tie in. So that gives you, basically speaking, an idea. Okie doke. Now, I'm going to go back to the slides, and I'm going to try and get in on the slides. Okay. Okay. All right. Meanwhile, now I want to switch gears. I want to show you another way in which architecture is, basically speaking, data architecture, sort of influenced a lot of my thinking. We're going to have a look at a grocery business, an online grocery business. There are never less than 900 million rows within partition tables, and the event data that we had to go and pull for this thing was in excess of 2.3 billion records at any one time. All right. Here's a small code sample that I pulled, and what it did was it was pulling a lot of data. And in this particular case, what I tried to do was try and get some data out of the table. And if you'll notice over here at the bottom in the little blue circle, you'll see that this query ran for 7 hours, 21 minutes, and 40 seconds before I killed it. Okay? So obviously, we have got an issue. Now, the reason you'll understand in a couple of minutes' time why this thing sort of ran so slowly. What am I trying to achieve here? Okay, it's the following. You've got various different systems that have got data, poor design systems to integrate with each other. Everybody developed their own little flipping system. And in developing their own little flipping system, nobody talked to one another. So you had to sort of, you know, use Keith Robinson method of trying to get the data out with a bit of sticky tape and a couple of pieces of string, you know, something that you would get out of your grandmother's favorite drawer. I don't know if any of you guys, have people out there, got, you know, one of these little drawers where you put everything in just in case you need it. Well, boy, we did need it. All right. In this particular business, we had one particular manager who thought GUIDs were the best thing since vanilla ice cream. And everything was used with anything that had a key field was done with a GUID. Now, this is great to use a GUID if you have no intentions of doing any reporting of it. But if I think about it to yourself and have to ask you honestly, what I want you to think about for the next couple of minutes until I mention it, is what is the major disadvantage of using a GUID when you are trying to, you GUID at a key, when you're trying to get data out of a multitude of tables. In our little imaginary scenario that we're going to talk about right now, which is pertaining to that GUID, we had in-client data. The client data wanted the data at the top, and he wanted the required amount of money that was spent on that thing by the customer. Now, the session data which was the intermediate, the middleware for all intents and purposes. It had a customer ID, it had an advertising GUID, and it had a customer GUID. All this data is bumped for obvious reasons. But the warehouse had a customer key, and it had an advertising GUID. Now, it was easy to get, if we start from the bottom, and we go from there to the middleware. But the customer GUID, you can see that that 1KWW Dudaki has got an entry in the session table, which is the middleware. But unfortunately, the customer GUID off to the right is null. Now, that would have been great to be able to join to the customer GUID on the top. So we're sitting with a scenario where you've got incomplete data. And it's very, very difficult to go and get this. And I had to go through contortions to be able to try and match things together. And at the end of the day, I just threw up my hands in total dismay. Now, the problem with the GUID is the following. Even if you use it as a clustered index, the GUID is a randomly generated number. That, a combination, a GUID number, I take that word back. And you're never going to get things ordered properly because it is randomly generated. So it's really a poor choice of a key. A very good close friend of mine who lives in California basically said, you want a good key, use an integer. And I think that we all agree that the best type of key to put in there, especially on a clustered key and a clustered index, is to use an integer key. And this is one of the big failings that we had. We even tried CTEs to get some of this data back and a combination of stuff like that using the indices that were built onto the existing system. Now, to try and get this going, first of all, we were summing things up. And we were summing amounts spent up. Now, that obviously produces a great amount of strain on the system. Not only that, on TempDB, and TempDB was always running out of space. A small query like this should not have taken 3 hours and 21 minutes to render. All I was trying to do was to try and get the sum of the sales and get a basket ID and a customer ID from the warehouse, etc., where the customer keys did this, and the data existed for the month between the 19th of June of 2012 and the 15th of July, which is less than a month. Now, 3 hours and 21 minutes, no person in their right mind is going to accept this as standard. So the question is, what is the issue? Where are my architectural problems within my warehouse? All right. Well, there was another team that was busy doing a super warehouse for all intents and purposes, which is a glorification enhancement of, how to make things really work a little bit better. In this particular case, what they did was they did a clustering key on, and a cluster index basically on a couple of keys in there, etc. There was a platform key, as you'll see there, which was basically speaking a partition number for all intents and purposes, and a store key, etc. Now, this did produce a certain amount of betterment in performance. And when I ran the thing with a CTE and tried to do, get the same data out, it seemed to come out a little bit faster, right? And so CTE, number one, CTEs always make things a little bit easier. However, the improvement within the indexes or the indices really did make a difference to it. So it's another thing that your indices are going to have to evolve as you go along. In this particular case, you'll notice that instead of the 3 hours and 21 minutes, or whatever the figure was, I can't even remember it, if you look down at the bottom, this took only 1 minute and 43 seconds to come back, which is a hell of an improvement. Attributed to what? Basically speaking, having your indices placed in the correct position, and more importantly, being able to say, look, the design that I had in the first place was, when I first started off, was okay at first. As we get busy and put in more enhancements, and I say that in quotes, put more enhancements into the system, we are going to have to change our architecture. We're going to have to do much better on our architecture to make our architecture perform better. We may be effective in what we're doing, but we're not being efficient in what we're doing when queries start running in 3 hours and 41 minutes to produce a couple of rows. And you know it as well as I do. This is a major issue. Okay. Now, the final point I want to touch upon when I'm going to do this, and this covers for both the banking scenario and my example of the grocery business. Metrics are a very important part in ascertaining whether or not your architecture is good. And the problem is we sometimes tend to forget monitoring metrics in a third dimension over time and see how things are doing, especially with loads, reports, and anything else that you may want to sort of track. You may find out that Steve Simon issues a report every day and he runs the report. Sometimes the report runs in a minute and a half. Sometimes it takes 5 and 6 hours to run the same report, depending upon what's going on. And the other thing that one wants to remember is you want to sometimes see the code and run things in Profiler, etc., especially when it comes to parameter sniffing. Because this thing here really got me by the guts at one particular stage about 2 or 3 years ago. How come things are running well? Or when I did the prepare the store procedure, everything was running well. And then when we go in to put the other parameters in, the thing takes 5 times as long. And it wasn't until somebody put me onto parameter sniffing that it really, you know, sort of came, the chickens came home to roost. So that's one other thing that you want to watch out for. Okay. Monitoring performance issues are another very important part of looking at the data warehouse architecture. And what I wanted to do is show you a little idea that I put together as a Heath Robinson thing for my boss when I was working in the grocery business, so that we could monitor the processes as they were going every single day and be aware, made aware of any anomalies within the system, so to be, sort of to speak, to be proactive in what we're doing. Here is a data systems monitoring tool that I put together, doing my own voice today, and it's got a whole pile of green squares. Now, this thing took me, with a no line, no more than about 6 hours to put together, and to modify it takes me 15 seconds. What you're looking at, and I'll show it to you in detail in a couple of minutes' time, is a whole pile of text boxes, nothing more than text boxes. Now, if you look at the left-hand side of the left-hand column, the one that's yellow, and you look at the second box down, which is green, you will notice, if you can, and you can see it on your screen, you will notice that there's a little red band about 1 millimeter wide protruding from there. That's deliberate, just to show you what's going on. Now, the trick was the following. In order to have a look if there was an anomaly, say, for instance, I have an error table, and if anything went wrong in the error table, I'm just giving it to you simplicity. I would write a query and say between a certain amount of time and certain amount of time, between this beginning of midnight today, which has just passed, and 23:59:59 tonight, if there are any errors, I want you to return the records. Now, what I played with there on the 2 rectangles with the little red strip on the side is the following. I played with the visibility property of the text box. If no records were returned, I made the visibility of the red box, which is underneath the green box, and we'll have a look at it in a minute. I made it, if there were records returned, I made that box, the red box, visible, and I made the green box invisible. Now, if there were no records reported from the error table and it came back with an empty data set, what I did was I made the red box invisible and the green box visible. Green means, okay, no problems. Red box means we've got issues. Now, what I did was, on the green box, there was no action. For those people that know about reporting services, the text box has got an action parameter, a property to it, in which case we could call a small report and it could show everybody what was cutting and you knew exactly what the problem was. If everything was green, everything is copacetic. But then I also needed, talking about now about the yellow box in the top left-hand corner, what I did was I had various different flavors, variations on things by Paganini. You can have any color you want as long as you know what the colors are. And you can say, well, look, if there's 5 records or if the record's is supposed to come out any time, and the issue is saying that there are no errors, for example, in the error report, if that's the way you have it, you can say make it yellow, in which case there's nothing, no issue, or you can make it green. You can do as many boxes on top of each other as you want. Now, moving down, you can see that on this particular day that I ran the thing, I've got an error on the batch packet error log, I've got one in the daily sales SAT, and I've got something that has occurred on the fact daily sales check. So if you look at all the boxes that I've got here, look at all the processes that I am monitoring in one screen shot. I mean, to me, this is phenomenal. Okay? Now, I've taken in this particular example that I've shown you, you can see that I've got the batch error log there in yellow, and you can see how I've split across the samples there. And underneath the yellow box, you can see I've exposed the red box. Now, in the red box, if this is the green text box, what I've done is if the green box will become visible only if there are no error messages. Now, when you set the visibility, it's based upon the fact that the thing is hidden. So it's either true or false. If it's hidden, it's going to be set to true. Otherwise, if hidden is false. It's a weird way of doing it. But in any case, it works. I've got a sort of if statement in there, a typical VB script statement in there, that if the color, whatever it may be, returned from the statement is green, then hidden is false because that green box is not to be hidden. It's supposed to be green and it's supposed to be seen. Otherwise, set it to true. And this thing seems to work. Now, the red text box, on the other hand, it's the same thing. What I'm doing there in this particular case is I'm looking at the color text box, and what I'm doing is if in this particular case with the red box, all right, if it comes back as green, the text box should be hidden, and if hidden is true, so it gets hidden, and otherwise it's false. So it's basically speaking a matter of determining whether or not you've got an error on what you're doing. Now, there's an action on the red box. You'll see that in this particular screen over here. There's your action, and what it does is it runs a particular report if that red box is visible, and the hand appears right on the red box, so you can click the report and run the report. So this is a very, very quick little monitoring tool that you can put together. You want the code? I've got the code zipped up. I'm more than prepared to share the code with you and all the databases that go with this presentation. Okay? Last thing I want to touch on, and I think that this is actually fairly important when it comes to queries, is aggregation in your warehouse design. Unfortunately, within the actual grocery business that I was in, there were a lot of issues with regards to the aggregation. You can see in this particular case here, we were doing a lot of aggregation on queries. This is a major hit, and I don't have to tell you that. It's a major hit as far as anybody's concerned, all right? So what you want to do is think about that within your design. As a matter of fact, at one particular stage, what I did was I landed up doing pre-aggregations over the weekend. It made things a heck of a lot easier. That particular query that you saw took 3 hours and 41 minutes to complete. And oftentimes, what you would find is you would find the TempDB gets maxed out. And this is a major problem because the only way, as we all know, to get TempDB to empty is to bring the server down and reboot the server. So, you know, the SQL server started again, stop and start. And this is a major problem. Okay? So SSIS is an answer, especially when you're trying to load or trying to pull data. Here, in this particular case, instead of using a piece of SQL to go and load the table and do the aggregations, what you can basically speaking do is use a piece of SSIS code. In this case here, the major difference is, and this is the thing that's beautiful about it, it tends to use memory and writing to disk as opposed to using it to maxing out the TempDB. So it's something you want to consider, all right? EMVs are a phenomenal thing to happen, and I want to show you, this is perhaps the piece of pièce de résistance of the whole presentation. And if you could just give me a couple of more minutes, I'd like to just show you this because I think that this is actually magic. I'm going to show you this live. The question that I wanted to show you here in this particular piece of code is the fact that you may want to monitor jobs, your jobs, etc., queries, whatever it may be running. In this particular piece of code, what I've got is I've got the piece of code that I put together using some of the DMBs out of MSDB to judge runtimes of various different processes. And you can see that in the one field at the bottom there called color, you can see that what I've got is I've got a green, yellow, and red depending upon the time at which the thing ran and against the average. In the fields I've got the run date of the query, I've got the runtime in seconds, the average runtime in seconds over all the days that have been run. I've got a piece of code that says if it's 40% deviation in any particular direction, more than 40% colored yellow or red, dependent upon it, gives me the average runtime. So this is a piece of code that I'll also be happy to give to you. And let's go and have a look at this piece of code in action. Okay, so I'm just going to go into my other instance here. Guys, can you see my screen now? I just want to make sure that everybody can see what I'm doing. I should have SQL Server up.
Yes, we can.
Yeah, we can see it.
Can you see the screen?
Yes.
Great. You can see the query plan.
Yes.
Great. Okay. Here's a query that runs against the database that I've got open. It's a production database, and you can see I've got a whole pile of code in here, which is gibberish, that I want to run here, and I'm going to see how long a particular, I've got a job that runs through the agent, which is helping me monitor the efficiency. Now, if I execute this particular plan, you can see that this was run. Here's the times, the average run time, etc. Okay, and this is the various different run times and the amount of time that it was run during the day. Look over here. When it ran at this particular time, at instance 7, it ran for 242 seconds. Therefore, it's colored green, red. Okay, over here, the instance ran in 2 seconds, so it's green. I don't know if we have any yellow. But you can see basically when this thing starts becoming long, in excess of a certain amount of time, you can see that the color changes from green and yellow, okay, to a whole pile of myriad of various different colors. So this is a type of thing that you could go and incorporate within your dashboard and use this thing on an ongoing basis to put this into a database table, and you can have a start and an end date, etc. And this is running, basically speaking, live. So in the meantime, in case anything is run again, I run the thing, okay. I can run, you can basically speaking, drop the table, please, and then you might be able to get it to run. All right, I run the thing again. There's maybe a couple of more runs on the thing, gives you an average run time, etc., in hours, minutes, and seconds. And this will run and keep a running average for you as many times as you want. So at least you can control your process and you control your query. You can control everything that you want. You have a finger on the pulse, etc. Every time you run it, if it's got a red value in it, you can get it to show up on your dashboard. So I think this is a pretty useful little tool. Okay? All right. So we had the memo. Right, home stretch. What are the takeaways from this particular presentation, and how does it tie in with the mission statement of your virtual chapter? Well, data warehouse architecture is obviously very important, and it's also important that you get table structure right for the reporting patterns. And I really, really harp on Michael Jackson. I'm old school. I'm 63 years of age. And I can remember learning when I put the box, for those people out there in audience land that are my age, you can remember taking the cards down to the card reader, and some student would always drop the box of cards, have to put them back together again. So we've learned over the years, we've come along in the tooth. The database structure, table structure, has to really be similar to the reporting patterns, especially when you're dealing with a data warehouse. You're not trying to get efficiency in loading data in there. What you're trying to do is get efficiency in loading, taking the data out. DALs may be a solution to your problem area. I know that I was able to gain a lot out of the DAL and using those particular DALs to be able to get efficiency out of it. And I took, as the person who had to go and fix darn queries, it really took a lot of strain off me and enabled me to do other things that, that I really, really wanted to do. Data must be cleansed and complete before you start going across the areas. Now, this is where DQS really comes in handy. And I'll tell you what, if you haven't looked at DQS yet, you're cheating yourself, okay? I did a presentation in October last year at the Nordic Rally, and it was absolutely very, very well received. I'm not trying to blow my own horn, but the point I'm trying to get across here is that Europeans are really now starting to look at their data quality problems. And if you say you haven't got a data quality problem, I say you lie, because we all have data quality problems. Reporting services can really be a great tool to show problematic areas, right? And you saw that in the little monitor, process monitor that I put up. I'd like to come into that on Monday morning and have a quick look at that before the phone starts ringing off the hook. I hate surprises, especially from senior management. DMVs can really be useful in putting these things together. And the problem is, and I'm guilty of it too, if you think about it and to thine own self be true, the problem is that we all do not know the full capabilities of the DMVs, every single one of them. And the only time that we get to know about these DMVs is when we really need it. Necessity is the mother of invention. And using Google. Finally, above all, revisit your overall data structure, your warehouse structure on a regular basis. It's really totally critical to do it. It's not a one size fits all. It's something that has to be evolved in the life cycle of your data architecture. Because at the end of the day, it really boils down to a matter of dollars and cents and hitting the income of the company, the revenue of the company, especially when you have unhappy campers in the field of users. And basically speaking, it results in a better understanding of challenges that you do pick up when you're trying to design an optimal financial warehouse and a grocery warehouse for that matter too. Thanks very much, people. I'll take any questions if there are any questions.
I see two questions here.
Yeah.
One is about discussing concerns or issues you faced with solutions regarding parameter sniffing.
Okay. If I understand the question correctly, here's the story with parameter sniffing. When you go and you test a query that you're going to make into a stored procedure, and you tend to test with certain values, and when you go and you run let's call it a query before it becomes a stored procedure, there's a lot of data and parameters in cache that are used in the compilation path of the stored procedure. Hence, the execution plan for when you create that stored procedure has taken into consideration the parameters that are in cache, the arguments that are in cache to the parameters. Now, if you go and create your stored procedure, and then you go and run it, okay, I created the query and I ran it with Winston as a cigarette. I don't even smoke. All right, and it ran and it comes out efficiently and I'm very happy and everything's running, and I create the stored procedure and I run it with Winston, everything runs well. The moment I go and change that and I make it into Salem, somehow if the structure is not right, what happens is it takes a hell of a lot longer to return the data, and that's because of the fact that in building the execution plan, it has taken into consideration the parameters. And what you have to do to get away from that particular problem is well described in an article, and I'll get the link to you. It's what I call toilet reading, because the thing is a beautiful article that is put together that's only got about 50 or 60 lines, and it describes efficiently and effectively how you can get by this thing by declaring variables within your query and using these, feeding the parameters into the variables that you're defining within the stored procedure, and using those things as part of your predicate, which you normally do, but I don't want to belabor the point. I will send I copy the link, and I'll have it on my website as well, to this little article. I think it describes it very, very well. It's somebody that put it together, and it'll show you the poor things that you get with regards to the parameter sniffing. It's a major, major issue. Okay, have I discussed that? I'll get you that particular article. I promise you, it's about a 20-minute read, less than 20-minute read. What other questions?
There was a follow-up to that question.
Yeah.
Okay. He was concerned, he was asking for experience or advice using distributed queries with linked servers.
Distributed queries with linked servers. Okay. It's going to be, when you're doing this type of thing with a linked server, you've obviously got the problem. You're testing, say, for instance, within a development environment, or you're linked to the production environment, which you really shouldn't, but to really thoroughly test queries, when I was working at the bank, you really had to work on a lot of live data in order to be able to test these things, and the only way we could do that was work on a linked server. I don't like it. I would rather recompile the stored procedures. I guess I'm old school. I'd rather recompile the stored procedures on the production server, where it's going to be clean and fresh. I don't know if I'm answering the question.
Oh, we have another question here too.
Yeah.
Let's see.
For those of you that want the code, sorry to interject, for those of you who want the code, I'll have it zipped up. Just give me tomorrow to do it, and I'll pass it on to your virtual chapter leader, and I'll also have it on my website, infogoldusa.com.
Regards to the memory usage, have you come across issues with large data sets returning?
Yeah. Yeah, it loads the memory up. Tremendous amount, especially when you're doing aggregation. And that brings the system to its knees. That's why in many cases, what I did was I did aggregations over the weekend and put them into a table. It's the wrong way to do it, but it was the only efficient, effective way of doing it. Let me just add one more thing to that. In the grocery business, this became very, very prominent, especially when you're looking at sales and you're looking at sales in categories. For instance, if you're looking at, for instance, food. Now, food can come down to lunch, dinner, and breakfast. Breakfast, we have cereal. We're already 3 layers down. Cereal, you can have Post, Kellogg's, or whatever it may be. Underneath Kellogg's, you can have Corn Flakes, Rice Krispies, Cocoa Puffs, you name it. So when you have to try and do the aggregation to come up to the top of foods or breakfast cereals or whatever it may be, there's a tremendous amount of hit on the table, especially if you're looking at a relational table and not working with a hierarchy structure. And this is a major drawback, because as you're aggregating up, you're obviously hitting TempDB. And there were numerous times when TempDB just got maxed out and brought the whole system down. So it is a major issue. Other questions?
I have this one here. It says, would interesting to use just one BOA and play with the border and fill would have to make a fairly thicker border. I'm not familiar with this, what they're trying to say.
You may have to make a thicker border if you wanted to. I mean, I suppose it, you know, to me, I wanted a quick and dirty solution. I didn't want to sort of make a masterpiece on the thing because, you know, I wasn't majoring in minors. You're quite right. Look, there's other ways that you could go and do the thing. One other way that I've thought of doing it was putting in a whole pile of graphs and gauges in there to make it pretty. But this is something that I basically wanted to put together myself to, you know, to avoid the crap coming down from the top. In other words, be prepared. The best method of attack is to, you know, defense is to attack.
Okay, I have a question here. We're going to be posting the recording to our website later. And the last question I see here is that does Stephen recommend a good tutor for DQS or a good book?
Okay. For DQS, the best articles are, what I would do is I would Google, I can't remember the name of the guy who did it. Oh, I'll tell you what I want you to do. Go and look up Lynn Langit, L-Y-N-N-L, her last name is L-A-N-G-I-T. And she has a couple of YouTube videos on data quality services where she takes you through from start to finish in using the data quality services. And she does it completely practically. It is a phenomenal video. There's one stretch at 40 minutes or 41 minutes, something or other, where it goes blank. The sound goes bad on it for about 1.5 minutes, but you're not really missing anything there. So my best bet is for you people that are interested in DQS to go and have a look at Lynn Langit's YouTube video, because I'll tell you what, it's spectacular. It'll give you within less than an hour an idea of how to run it. There's not that many really good books on it. If anybody's interested in it, get hold of me at infogoldusa.com, shoot me an email, and I'll give you a complete copy of the presentation that I did in Copenhagen last year in October. You can have the whole thing, the databases and everything else like that.
Okay, well,
Oh, that's all their
question.
questions I see.
Anything else?
No, that's all I'm seeing here. I want to thank you for giving the presentation today, and thank everyone for attending.
Yeah, and if anybody wants to get hold of me or has any questions, please do. I just love sharing the knowledge. And I know they say what goes around comes around. Other people help me out. So if anybody's interested, you can get hold of me at either InfoGoldUSA or at steve.simon@sqlpass.org. I want to thank you all very much for the opportunity to address you and It's really super to see a great turnout. Thanks ever so much. So I'm going to pass it back to you.